Hello everyone, my name is Bappi Hamed and welcome to my YouTube channel. So guys, in this video we'll be discussing one very interesting object detection model called YOLO-World. YOLO-World is a zero-shot object detection model. You can use YOLO-World for detecting any kinds of object without annotating any kinds of data. So in our traditional object detection model, what we use to perform, let's say if I want to train any kinds of data, let's say I want to train one custom model on top of, let's say, a dog dataset. So what I have to do, I have to first of all annotate the dog images. Okay, then my model will be able to detect that particular dog from the image. But if you're using YOLO-World, so here you don't need to annotate your image. Instead of that, what you have to give the classes as a prompt to the model, and your model will automatically understand the prompt. Based on that, it will detect the object in that image itself. I will also show you the practical demonstration of this model, like how we can set up the entire environment and how we can use the model for the detecting any kinds of object. So let me show you the amazing research paper on top of this model has published. So here you can see this is the research paper. The research paper name is YOLO-World Real-Time Open Vocabulary Object Detection. Okay, and here they have explained about this model, like what are the things they have developed inside this model. Even you will also see the architecture of the model, everything they have given. So if you're interested learning about this model, if you want to deep dive it, please try to go through this particular amazing research paper. You will get each and everything. So here you can see they introduced something called YOLO-World, an innovative approach that enhance YOLO with an open vocabulary detection capabilities through vision language modeling. So they're using something called vision language modeling here. They're also utilizing something called generative AI technology, okay, to understand the prompt. That means whatever classes you are giving as a prompt, to understand this particular prompt, they're using something called large language model, okay, in the backend. So again, you can go through this paper, you will get each and every idea, okay, what is the architecture they're using and all. And here is the benchmark graph. You can see this is the frame per second on the V100 GPU. And here you can also see the MAP score of this particular model. Apart from this model, we had some more model previously, like grounding Dino-T. This model was available. Then Glib V1T. This model was available. But if you see the performance of YOLO-World, so the performance is pretty good based on the FPS. That means frame per second. If you're also running this model on the video, so you will get good frame per second here. So this model is having actually three variant, like YOLO-World S, that means this is the small model, YOLO-World M, that means this is the medium model, and YOLO-World L, that means this is the largest model. Okay, so now let me show you how we can set up your environment and how we can use this YOLO-World model for the object detection. So for this, you can visit one website called supervision.roboflow. Okay, supervision.roboflow. So here is the website. So let me open it. So here you will see one section called cookbook. Just open this particular cookbook. So here actually we'll get the notebook of this zero-shot object detection with YOLO-World. So I don't need to write the code from scratch. Everything is available here. So let me open this particular notebook. So here is the notebook section, guys. So try to open this Colab notebook. So inside Colab actually will be making the setup. So guys, you can see this is the notebook, and here already some example they have given, like how the detection is working and all. So here you can see some example of the YOLO-World. After detecting, they got the results and it is pretty good. So if you see the results, actually it's pretty good. So I will go below. First of all, what I have to do, I have to connect with my GPU. So make sure you connect your GPU. So for this, just click on the runtime and select the GPU here. So change runtime type, select a T4 GPU. And if you're using Colab Pro, you can also use A100 and L4 GPU as well. Okay, it's up to you. So as of now, I'll be selecting T4 GPU because here I'm using free Colab. Now let me connect my notebook. So my notebook is connected. The first thing I'm going to check my GPU. So for this, you have to run this command called NVIDIA-SMI. So it will actually give you your GPU configuration, like what kinds of GPU you got. See, here I got actually Tesla T4 GPU. Now here the first thing we'll be doing, we'll be setting the home directory. So for this, actually I can use the operating system package, and there is a method called get CWD. That means get current working directory. Now I can see my current working directory is content. That means this is the current working directory. Okay, so this is called actually content directory. Now here, first of all, I have to install some package. So the first package actually I need called inference, because inside inference actually we are having this YOLO-World model. And to install inference, this is the command you can follow. Now let me install. So installation may take some time. Let's wait. Once this installation is complete, I will come back. So guys, you can see installation is done. Now let me install another package called supervision. And I think you already know what is supervision. Supervision we can use for let's say rendering my image or rendering my video, okay, after getting the detection. To install supervision, I can use this command. So let me install the supervision as well. And here I'm trying to install some specific version. So if you need any other version, you can check it out. So there is a PyPy website. You can go here and you can check the different version. Now installation is completed. Now first of all, I have to import all the library. So here I'm importing like CB2, that means OpenCV, then supervision. TQDM actually I'm importing if you want to see the progress, okay, progress of any, let's say, loading. So you can use the TQDM. And here I'm importing this YOLO-World from the inference. Okay, inference package you can see. So from inference models YOLO-World, and I'm importing this YOLO-World class. Okay, so now let me import it. Now the next thing what I have to do, I have to download some example data. So this data is already available inside RoboFlow website. Let me show you. So this is the image actually present inside RoboFlow server. So we'll be downloading this particular image, and on top of this image actually we'll be doing the inference. So let me close it and let me open up my notebook. And there is another actually command you can see. So it will download one video, okay, from the RoboFlow servers. As of now, I don't need the video. I'm going to comment this line. Now let me download this image first of all. Yeah. So now you can see I don't need this line. So this is the image location inside content doc.jpg. Now let me open. See, this image is downloaded already. So this is my doc.jpg. Now let me assign the path of this image. Now the next thing, you have to initialize the YOLO-World model, and to initialize you can use this YOLO-World actually package you have imported. Inside that you have to specify the version of the model, like the variant of the model you want to use. So as I already showed you, YOLO-World is having 3 different model, S, M and L. Okay, so here I'm using L model, okay, large model. But here you can choose the model based on your machine configuration, based on your problem statement. Let's say you need let's say higher accuracy, that time you can use a big model. But let's say you need actually higher inference time, that time actually you can use smallest model. Okay, it's up to you. Now let me initialize the model. See, after initialization, what you have to do, you have to pass the classes as a prompt. Now in this particular image, just try to figure out how many classes actually you can consider. See here we are having one dog image, and in the dog actually what are the classes you can consider? You can consider the eye of the dog, then ear of the dog, even a person is also there. Okay, so here I have mentioned different actually classes. You can see person, backpack, that means backpack is also there. So this is a bag, there is a bag. Okay, now we are having something called dog, eye, nose, ear and tongue. Okay, so these are the classes I'm considering in this actually image. You can also consider the car. So I think car is also there. See, car is also there, but it's not visible, that's why I haven't mentioned here. Now this is my classes. Now we can pick any kinds of data, and based on the data actually just try to define the classes here. Now you have to prompt these classes, okay, to the model. For this you can use this particular method called set classes. Now see, if I execute this program, first of all it will download the model. Okay, it will download the language model, and it will try to understand the prompt, and it will create a embeddings, okay, embeddings representation of the classes you are giving. Based on the embedding actually it will try to decide what kinds of object it has to detect. Okay, all right, now first of all I will load the image with the help of OpenCV, and for the inference, I'm going to use one function called infer, and inside that I'm going to pass the image, and whatever detection actually I'll be getting, we'll be using supervision to collect those results, and we'll be keeping inside detection. Now let me show you. Now here inside supervision, you can also set some parameter like what will be the thickness of the, let's say, bounding box, what will be the text thickness, everything you can set here. So I already set some default actually thickness value and all. So let me execute. Yeah. So finally, if you want to render your image, you can use supervision.plot image. Okay, inside that you can give your annotated image. Okay, the image actually we are getting after the detection, and you can also define the image size. Now see, if I execute this program, so you will be able to see the prediction. Okay, see, this is my prediction, and it has only detected the person and dog. Okay, the person and dog, but here we mentioned actually lots of classes. Okay, but it is not able to detect those classes as well. See, if it is not able to detect, what you can do, you can decrease the confidence score. Okay, you can decrease the confidence score. So here is the section, you can adjust the confidence score. See, as of now the confidence score actually I had given 0.003. I just decreased the confidence score a little bit, but again it's not a recommended. But if you decrease confidence score in the YOLO-World, you will get actually good detection at the end. Okay, let me show you. So if I execute the same code again, only what I'm doing, I'm decreasing the confidence. Okay, now see, again I'll be executing the line. That means I load the image, and I will just render with the help of supervision. Okay, those detection actually I'm getting after the prediction. Now guys, you can see this is the results I'm getting. So it is able to detect eye, nose, tongue, dog, person, backpack. Okay, everything it is able to detect. But the thing is, like, it is detecting actually twice some of the detection. So to handle this one, what we can do, we can use something called NMS. That means non-max separation. I think you know what is non-max separation inside object detection. So let me execute this code. See, here I'm using with NMS. Okay, so NMS will try to actually delete these at the duplicate detection. Now if I again execute the visualization example, now see, this is my final results. Now you can see detection is pretty good and the confidence score is also good here. Okay, so that's how you can use any kinds of image, and without annotating those images, actually you can do the inference with the help of YOLO-World. Okay, YOLO-World actually object detection model, and this is one of the amazing model they have developed. They have also integrated generative AI concept inside that, and they created this amazing model. Okay, now here video related code is already mentioned. So only what you have to do, you have to load the video instead of image, and you can do the same thing. Okay, it's the same step you can follow for the video inference as well. So I'll leave it to you so you can actually export. I will share this notebook with you. Even I will also share the research paper and the website link. Okay, so yes, this is all about from this video. I hope you liked it. So thank you for watching this video, and I will see you next time.